Hello there. This is the second part in a series meant to explain topics related to threats in the cyber realm. In our previous post, we explored how ClickFix has been abused by threat actors. Today, we're going to explore an evolution of that initial access technique which security researchers think may gain traction. FileFix. We constantly hear about the cat and mouse game in information security. With that in mind, defenders aren't simply waiting for the opponent to make their next move. We're constantly trying to think ahead and gather information so that we have detections in place from previous techniques or phased out in favor of newer ones. The community relies on one another in this regard. Recently, a researcher named Mr. Docs has speculated that this attack may expand, having users enter code into the Windows File Explorer itself. To fully understand what we're about to discuss, a brief conceptual explanation of path is required. A lot of you may be familiar with the concept simply using different terminology, like folders. On all operating systems, the machine needs a way to locate applications and resources it needs to continue operations. Behind the scenes, each user will have what's known as an environmental variable. Typically, this will include a path, or a series of folders on the file system where the operating system can look for applications or programmatic dependencies. Windows users can view their path by opening PowerShell and executing the $env:path command. One of the main path locations for all modern users of Microsoft Windows is Windows System 32. The majority of programs the operating system needs to function are stored here. When you hear us speak or read about lull bins or living off the land binaries, this path is where the mainstay of them are stored on disk. As we just laid the groundwork for, Windows knows where to locate binaries based on the path set in a user's environmental variable. Microsoft has gone above and beyond with an additional feature allowing users to execute any application from their path through File Explorer's address bar as well. When using this feature, command aliases are acceptable for execution. In other words, simply typing in CMD in the address bar of Explorer and keying in Enter will launch a command prompt. In addition to the features we just demonstrated, Windows has a built-in protocol known as SearchMS. SearchMS exists for users and administrators to literally search for something using the Universal Resource Identifier, or URI, which includes a Windows feature called Windows Universal Naming Convention, or UNC, file paths. That's just fancy speak for URL. While that might seem innocuous to someone unfamiliar with Windows internals, it's quite meaningful. Users can quickly access SMB shares by simply pasting in their location in File Explorer. How can threat actors abuse FileFix? Since threat actors are already proficient at getting a user to paste into the Windows Run dialog, it's not a stretch to think they may be able to get users to paste into File Explorer's address bar. In fact, there are keyboard shortcuts built expressly for this. The lure will presumably be an interesting or required document, but imagination is the only limit to the method. Mr. Docs released the POC written in HTML on his site, which explores how it might work. We've adapted the code slightly for our scenarios. The technique abuses similar social engineering to ClickFix. Back-end code presents a user with a fake site to display benign-looking instructions, which ultimately allow a threat actor to execute malware. Here, the user is asked to copy the location of the document themselves by clicking Copy, then paste it into File Explorer's address bar with the keyboard shortcuts and the button that launches File Explorer. The real code the user is copying is similar to what we explored last time, shown in the bottom of the screen. By inserting a large amount of space between the command and the commented code, which is all that is presented to the user, the attacker hides the portion of the code which will be pasted and executed from the user's view. After hitting Enter, the user has executed the malicious command. Why is this more interesting than regular ClickFix? Firstly, and more mundanely, an attacker can still trick a user into requesting a remote resource. However, if the attacker builds functionality via a WebDAV server, the initial loader can be made to appear more like a legitimate file download to the user. This piggybacks off recent campaigns we've seen where WebDAV servers host a .lnk file for execution. Most of these were initiated in the spring of 2024 and have tapered off, but the tactic is not dead. The second issue is credential harvesting. When using Windows Universal Naming Convention pads, the remote server can subtly ask for authentication. In an effort to be as smooth and simple to manage large environments as possible, Windows simply obeys this request and sends a user's NTLM hash to any resource that asks. Unless this is explicitly forbidden via administrative hardening in the registry or group policy, there is no way to stop it. Unfortunately, Microsoft views this as a feature, not a bug, although they are well aware of the issue. We've adopted the POC, abusing the Windows Universal Naming Convention, to reach out to an attacker-controlled server, which will request the NTLM hash of the victim. Displayed on the bottom portion of the Windows screen is a mock-up of that malicious code a threat actor may use to conduct any attack. The screen on the right displays the server, which will request the NTLM hash. The victim will provide this hash with no interaction after the exploit is triggered. As you can see, we've collected the user's hash, and our exploit has been run. With the hash acquired, an attacker has two options: crack the password offline, meaning get the plaintext password of the hash, or potentially pass the hash in an attack where cracking the password is unnecessary. Passing the hash is a way to echo a user's encrypted password back to Windows, skipping a step in the authentication process of converting it to a human-readable plaintext. Thanks for tuning in as we reviewed FileFix, the next iteration of ClickFix campaigns. Please reference our blog posts for methods of bolstering resilience to NTLM attack and specific protection strategies for this campaign.